So we continue representing the relationship between two sets. Let me just clarify that for a set to be a subset of another set, all the elements of one set have to be contained in the other set. For there to be a relationship, a proper subset between sets, there has to be at least one more element in one set that's not contained in the other set. Also keep in mind that once a set is a proper subset, it is automatically a subset, but not the other way around. So as we look at A, we have the set D, which contains Nokia, Samsung, and Motorola. And in J, we have Samsung, Motorola, Sony Ericsson, Nokia, and LG Electronics. Now, since all the elements in set D are also contained in set J, then we could say D is a subset of J. And since J contains at least one more element that's not in D, then we could also say that D is a proper subset of J. And there you go. And we do that for each one as we go through these. So for F, we have Nokia, Samsung, and NEC. In set J, we have Samsung, Motorola, Sony Ericsson, Nokia, and LG Electronics. So we can see that Nokia, Samsung, and NEC, these elements are not all in J. So we can say that F is not a subset, and we just put a subset with a line through it, of J. So if a set is not a subset of J, it's also not a proper subset. For C, we have the set R, which is a set of all elements B, such that B is a flightless bird. And then U, we have a roster method here, which shows kiwi and ostrich. There are more than just two flightless birds. So the set of elements in U are all in R. You could think of other birds, a penguin or an emu are also in here. So we could say that U is a subset of R, and U is also a proper subset of R. For D, we have set E is the set of all elements E, such that E is an element of the natural numbers, so E is the natural numbers, and E is an even number between 20 and 30. And then we have O, the roster method here, which lists 22, 24, 26, and 28. So you can see that all these elements are also contained in here, but also all of these elements are also contained in here. So we can say that E is a subset of O, and we could also say that O is a subset of E. But they are not proper subsets because there has to be at least one more element in one of the other sets for it to be a proper subset. E, we have the empty set, T is the empty set, and L is also the empty set. These two sets are equal to each other. So we could say that T is a subset of L, or we could say that L is a subset of T. And then finally for F, set S is the set of athletic shoes. There's a bunch of different athletic shoes. And then A has these elements here, and you can see that all these elements are contained in S, so then we can say that A is a subset of S. And since there's at least one more athletic shoe other than these four listed here, you could think of a few: Puma, Nike, Converse, then we could say that A is a proper subset of S.